Hello students, welcome to today's session of chemistry. As you all know, we have started with the seventh lesson of your syllabus, that is elements of group 16, 17 and 18. We call them P block elements. In the previous session, we started studying about the compounds of elements of group 17, in which first compound we studied is chlorine. Its methods of preparation, its physical properties, its chemical properties and uses we learned about chlorine. Now, the next compound of group 17 is hydrochloric acid, which is there in your textbook. But in the last week, board has declared that 25% of the syllabus has been reduced for this year because of the situation of COVID-19, in which HCl is deleted, as well as about group 18 compounds of xenon are also deleted. Hence, next compound we will learn about is interhalogen compounds, which is there for this year. So, what is mean by interhalogen compounds? A binary compound with halogens is called interhalogen compound. Halogens, they react with each other to form compounds. It is very rare thing because generally the elements of the same group don't react with each other. But because of the difference in electronegativity between two or more halogen atoms, they combine to form species or compounds which may be ionic or neutral, and the neutral molecules are called as interhalogen compounds. As we interhalogen compounds are the compounds formed by halogens themselves. Example we will see like CLF, BRF3, IF7, both the elements are halogens. Chlorine monofluoride, bromine trifluoride, iodine heptafluoride, etc. Now we will see the classification of interhalogen compounds. Depending on the composition, these are classified into four types. Like this, first type is XX dash. That means both the halogens are single, and this is the example will be CLF, that is chlorine monofluoride, BRF, that is bromine monofluoride, bromine monochloride, iodine monochloride, iodine monobromide, etc. Any combination you can do. Second type is XX-3 because the general formula is XX-N. Hence XX-3, N is 3. Suppose 3 X dash element or X dash atoms if we take, the compounds will be ClF3, BrF3, IF3, that is trihalide, iodine trifluoride, bromine trifluoride, like that. Likewise, pentahalide also is possible, that is XX-5, that means chlorine pentafluoride, bromine pentafluoride, like that. Likewise, heptahalide is also possible, that means X dash 7 X dash atoms will combine with a single X, that means IF7. Only one compound is there, IF7, iodine heptafluoride. Thus, the general formula will be XX-N. Then what is the rule for the formation of these type of compound? The rule is like this. X will be the halogen atom having larger size and more electropositive, while X dash will be the halogen having smaller size and more electronegative. We have seen the periodic trends. As we move down the group, the elements which are located below, that means as we move down the group, the atomic size increases. And as we move down the group, the electronegativity decreases. That means halogens which are at lower side are less electronegative and larger in size. That means X will be always the halogen which is at the lower side, and X dash will be always the halogen with smaller atomic size and higher electronegativity, that means which is located upper to related to X. So X dash combination will be like this. X will be the halogen which is at the lower side and X dash will be at the upper side. That means if we consider the sequence, fluorine, chlorine, bromine and iodine. As we move down, the first element is fluorine. That means fluorine will always be X dash because it is at the topmost position with highest electronegativity, smaller atomic size. And if we consider between chlorine and bromine, bromine is at the lower side, that is more electropositive, larger in size, then bromine will be always X as compared to chlorine. Hence, BRCl is possible. Okay, so X dash N, the condition is like this. X dash is more electronegative and smaller in size, or we can say the one which is at the upper side will be X dash, the one which is at the lower side will be X. The combination will be always like this. So this is the classification of interhalogen compounds. Now we will see the general characteristics of interhalogen compounds. The compound is always considered as halide of X, not X dash, halide of X. For example, ClF, it will be the halide of Cl. The name will be chlorine monofluoride, halide fluoride. So, halogen will be the X and halide will be the X dash. Hence, the name is chlorine monofluoride. Halogen having a larger size is chlorine and is more electropositive than F, and hence the name of the compound will be chlorine monofluoride. N is the number of atoms of X dash attached to X always. Now, second characteristic. Interhalogen compounds have always even number of atoms. Total atoms if we count. ClF3 total 4, IF7 total 8, BRF5 total 6. So all the interhalogen compounds contain even number of atoms. Hence, any example if we take, the number of atoms will be 2, 4, 6, 8 like this. Next property or next characteristic. The properties of interhalogen compounds are generally intermediate between those of halogens from which they are made. That means if chlorine and fluorine, if we consider like ClF3, the properties of interhalogen compound or ClF3 will not be those like chlorine or like fluorine. They are intermediate between these two. Next characteristics. The central halogen atom exhibits different oxidation states in different interhalogen compound. Consider central atom, that is first one, X. If we consider chlorine in ClF, it is a plus 1. In ClF3, it will be plus 3. Like that. So, oxidation state exhibited by central halogen atom are different. Next, number of X dash atoms in the compound is always odd. Total number of atoms in a compound, it is always even. But X dash atoms in the compound is always odd. The reason is, if we consider all the halogen atoms have 7 electrons in the last shell. That means only one electron is needed to fulfill the outermost shell. And if d orbital, when it is available, if they form a compound with another element, they get splitted up. That means last p orbital, it has 7 electrons. If it is splitted up, only one orbital if it is splitted, then 3 unpaired electrons will form. Hence, 3 X dash will come to form compound. And if 3 of the last p orbital, they become single occupied, that means splitting of 2 orbital takes place, then 7 unpaired electrons are available and hence they form 7 or X dash, 7 X dash can come and form compound with X. Hence, X dash atoms will always be odd. All are diamagnetic. When interhalogen compound forms, that means all the unpaired electrons will be paired and that means they become diamagnetic. So these are the general characteristics of interhalogen compounds. States of interhalogen compounds at 25 degrees Celsius, that means at room temperature. We will see one by one. First type is XX dash. That means monohalides, halogen monohalides. First example, suppose we take chlorine monofluoride. It is colorless gas. BRF is pale brown colored gas at room temperature. BRCl is in gaseous state. But ICl, iodine chloride, is in solid state. It has two allotropes. Alpha form is ruby red colored while beta form is brown red colored. IBR, that is iodine bromide, is black colored solid. Now, second type is XX-3, in which chlorine trifluoride ClF3 will be colorless gas, BrF3 bromine trifluoride will be in liquid state yellow green color, while IF3 is yellow colored powder, that means solid state, while ICl3 is a solid of orange color. XX-5, in which IF5 is colorless gas at room temperature, but at 77 Kelvin it is in solid state. BrF5 is again a colorless liquid like ClF5. XX-7, only one compound is available, that is IF7. It is colorless gas. So these are the states of interhalogen compounds at room temperature. Now, let us consider methods of preparation of interhalogen compounds one by one. For the first type, that is XX dash, the first method is a direct combination of the halogens. Suppose we want to prepare chlorine monofluoride, then take chlorine and fluorine in equal volume, and at 523 Kelvin in copper vessel they form chlorine monofluoride. Likewise, iodine and chlorine in equal volumes, if we react with each other in presence of an acid, then they give you iodine monochloride. Same way, bromine chloride can also be formed by taking bromine and chlorine in equal volumes. Second method of preparation of XX dash will be reaction of halogen with interhalogen compound. So to prepare interhalogen compound, we have to take interhalogen compound. But the reaction will be like this. Bromine on treatment with bromine trifluoride gives you bromine monofluoride. And there is one special method to prepare iodine chloride. And the reaction is between iodine and potassium chlorate that gives you iodine monochloride along with KiO3. So this is special method for preparation of iodine monochloride. Now this is all about first type, that is XX dash. Now we will prepare XX dash 3 type of interhalogen compound. That also has same method, that is direct combination. But now for monohalide preparation we have taken equal volume of halogen, but for trihalides we have to take excess of X dash. That means chlorine reacts with excess of fluorine to give you ClF3. The same way, fluorine in excess react with bromine to give you bromine trifluoride. If we take them in equal volume, it will give you monohalide. If we take excess of X dash, it will give you trihalide. So iodine with 3 times chlorine will give you ICl3. So this is first method of preparation of XX-3. Second method for the preparation is again reaction of halogen with interhalogen compound. Like with bromine on treatment with ClF3, chlorine trifluoride gives you bromine trifluoride along with bromine monochloride. So this is next method for preparation of XX-3. Only these methods are included in your syllabus. Now we will see the properties of interhalogen compounds or chemical properties one by one. First consider XX dash. Thermal stability, if we consider, then the sequence will be like this. ClF is more stable than ICl, then IBr, then comes BrCl, and then comes BrF. So the compound ClF is the most stable, thermally stable compound. Now, second reaction we are going to see is hydrolysis. What is hydrolysis? Hydrolysis means reaction with water. Now, BrCl on water gives two acids. One of them is oxoacid, HOBr, and second is HCl. The same way, ICl on hydrolysis, that is reaction with water, gives HiO3, iodic acid, HCl hydrochloric acid, and iodine. And this ICl3 on hydrolysis again gives HiO3, that is iodic acid, hydrochloric acid, but instead of I2 it gives ICl. Now we will see autoionization. Autoionization, that means separation into ions. Now, or disproportion we can say. BRF on disproportionation gives you bromine and BRF5. This is autoionization reaction. Now, in the same way, if we consider ClF3 on autoionization gives ClF2 positively charged and ClF4 negatively charged. That is autoionization. We get two ions. In the same way, ICl3 at 341 Kelvin gives you ICl and chlorine. So this is autoionization reaction. In the same way, if we consider fluorination, that is separation or reaction with fluorine. Uranium on treatment with chlorine trifluoride gives UF6 hexafluoride, uranium hexafluoride along with ClF. So this is fluorination. That means uranium is attached to fluorine, hence it is fluorination. Now, next reaction is addition across olefins. Olefins means alkenes. Alkenes always undergo addition type of reaction that we know. So, when ethene is treated with ICl, then it gets splitted up and across the double bond gets added to give you this compound. 1 chloro, 2 iodoethane, we can say. So, these are the chemical properties of interhalogen compounds. So, this is given in tabular form. So, write down it separately in your notebook and try to remember those. Now, next we are going to say are the uses of interhalogen compounds one by one. The first type is XX dash, in which if we consider iodine monochloride, it is used to determine iodine values of oils. That means percentage of iodine present in oils. Again, it is used for the catalyst as a catalyst for oxidation of arsenic. In the reaction of arsenic or oxidation of arsenic, ICl is used for as a catalyst. For preparation of polyhalides, so it is used. Next type is XX-T, in which they are also used for preparation of polyhalides. Poly is many halogens come together to form polyhalides. As fluorinating agent, X-3 is always fluorine and excess fluorine is there, hence it is used as a fluorinating agent. It is used as a solvent, non-aqueous solvent. Aqueous solvent means water. As you know, most of the reactions we use water as a solvent, but when there is a condition or requirement for non-aqueous solvent, then these trihalides or interhalogen compounds are used. Now, let us consider some structures of interhalogen compounds. Now, the first monohalide we are going to see, the structure of it will be like this. It is linear. Generally, monohalides or mono XX dash type of compound, they are linear. That means they are arranged in one line. Now, the trifluorides. Trifluoride structure, if we consider ClF3, then the structure is like this and the geometry is bent T-shaped. It is almost like T-shaped, only the angle is 89. That means the fluorines are not exactly as T-shaped but somewhat located with an angle of 89, hence it is called bent T-shaped. Same way, BRF3 is also bent T-shaped. The angle between the fluorine is 86 instead of 89 here. Now consider structure of bromine pentafluoride. The structure is square pyramidal. That means bromine and these four fluorine are in one plane, suppose horizontal to floor. Then fluorine will be below that plane and there is one lone pair above that plane. and hence it looks like pyramid. So it is square at the center and one fluorine below, giving it a shape of square pyramidal. Same shape we get with chlorine pentafluoride. It is also square pyramidal. So these are the structures which are included in your syllabus of interhalogen compounds. So this is all about interhalogen compounds. That means we learned about their methods of preparation, their chemical physical properties, their characteristics and structures. Now we will start with group 18. As I told you earlier that compounds of xenon have been deleted for this year, that means the remaining part of group 18 is only the uses of helium, neon and argon. So let us see the uses. Now first helium. Helium is very useful. It is used for many, that means it has many applications. For many purposes it is used. Mixture of helium and oxygen is useful for artificial breathing of asthma patient. Asthma patient, as we know, they are short of breath sometimes. So at that time, their artificial breathing can be done by helium and oxygen, a mixture of helium and oxygen. Same mixture can also be used for respiration by sea divers. Sea divers, they carry oxygen cylinder because they go deep in the sea where they may be short of oxygen, and for that oxygen cylinder they carry contain mixture of helium and oxygen. For filling balloons, a mixture of 85% helium and 15% hydrogen is used. Helium is also used for producing inert atmosphere. This is a very important use of helium. Inert atmosphere required for welding purposes as well as in the metallurgy. What is inert atmosphere? That means if the regular atmosphere, if we use in metallurgy, which contains oxygen, nitrogen like reactive element, they may react with the same metal, or in welding also. So, inert atmosphere, as helium is inactive or inert, hence that atmosphere, if it contains helium, it will not react with that metal which we are going to react in metallurgy. Hence, to create inert atmosphere, generally helium or inert gases are used. Liquid helium is also used for producing low temperature required in research. For research purposes, suppose low temperature atmosphere is needed and then that liquid helium is used. Again, it is used for production of lasers in gas thermometry. So, this is the use of helium. Again, few more uses are there. It is used as shielding gas for arc welding. Again, for welding in supersonic wind tunnels. In tunnels, supersonic wind tunnels, that is supersonic trains are going to come now in future, where those tunnels they have helium gas in it. Helium nucleus is used for bombarding particles in a disintegration of atom. Disintegration, that is separation. For disintegration, atom, if we want to separate it, then it is bombarded with helium and nucleus. That is, in nuclear chemistry it is used. Used for magnetic resonance imaging to get the images. So these are the uses of helium. Now consider the uses of neon. Neon, as you know, all the street lamps, they are neon lamps we say. So that means it is used in lamps and signboards which are glowing. So these signs, why it is used in road lamps? Because these signs generally that glow at night, the advertise boards, then and the street lights can be visible from longer distance, and they are also visible in midst of fog. Hence, neon lamps are used on street. Again, a mixture of neon and helium is used in certain protective electrical devices like voltage stabilizer. Voltage fluctuation can be avoided by using voltage stabilizers. So this is protective device. And in protective devices, mixture of neon and helium is used. Next, neon is used for production of lasers and in fluorescent tubes. Next is argon. Argon is again used to prepare inert atmosphere for welding and steel production. Mixture of 85% argon and 15% neon is used for filling electric bulb to increase life of filament. So inside the bulb, the inert atmosphere is produced by this combination. Again, in filling fluorescent tubes and radio valves, argon is used. Argon is mixed with neon to get lights of various colors that is used for advertisement purposes. So these are the uses of argon, and this is all about group 18. Now this much syllabus is there in your for this year for board exams. Hence, we concluded with the seventh lesson, that is elements of group 16, 17 and 18. Now, time for assignment. You have to write the general characteristics of group interhalogen compounds. You have to write the uses of helium, neon and argon. As well as you have to draw the structure of ClF3 and BrF5 with their geometry. So this is all about assignment. Now, as we have concluded with this lesson, if you have any doubts after listening to all videos, you can ask me on my personal WhatsApp number. Thank you.